our first panel session of the morning, which is going to focus on the role of AI and machine learning in the shift to more workforce robotics. And I'm joined by three colleagues across the robotics landscape that I'd like to just take a moment to introduce to all of you. And then we're going to dive into our discussion. And again, just as a reminder, if you have questions that you'd like to pose to us collectively on the panel, please pop those into the Q&A session window, and we will try to grab as many of those as we can during the course of the discussion. So with that, I'd like to first introduce James Kinsey, who is the CEO for Humatics Corporation. Good morning, James.
Good morning. Thanks everyone for your time today, and looking forward to a really great panel discussing a really exciting time in manufacturing and really the workforce robotics as a whole. I think we've done a lot in the past decade, but I think the next decade is what really excites me as we bring together a lot of that and the role that robotics hardware and AI brings in that. So it's really exciting, to join the panel today and have some great conversation on the topic.
Thanks, James. Excited to have this conversation. So our next speaker we just heard from is Raj Ikat from iMerit, again, who's part of this panel discussion. Welcome back, Raj.
Hey, everyone. Thanks for this opportunity, and love to chat with you guys.
And we're also joined this morning by Deepan Paul, who is the founder for Voyage. Good morning, Deepan.
Hey, Chris, thanks for having me on this panel as well. And I think it's a fantastic cohort of companies that you guys have assembled here. So really exciting event. Looking forward to it.
So thank you all. I just to kick things off, I thought it would be useful for perhaps starting with you, James, just to give a little overview of what Humatics is doing in the robotics space. And I'm going to ask each of you to kind of cover your areas just to give folks a sense of all the things that you're accomplishing in the robotics industry. And I'll start with you, James.
Yeah, thanks. So Humatics, we focus on micro location. So that is basically positioning technologies for robotics at the millimeter or better level. So basically we have a full stack positioning product that includes RF, software systems, AI that is, positioning to, in some cases, hundreds of micron precision and accuracy, hundreds of times a second. We basically can then take this into a work cell in manufacturing. So think, you've got a work cell with a couple of different robotic arms, and we can enable a very flexible, agile manufacturing process, independent of the individual capabilities of all the platforms. And in fact, we pride ourselves that we're platform agnostic. We can work with over a dozen different robotic systems, and, provides value on a couple of levels. One is by enabling problems like assembly in motion. So think a car engine never has to stop as it moves through the line, and you can torque the bolts. That allows you to increase productivity. Also, that smart tool that's tightening those bolts has incredible amounts of data. We give all the positioning context behind that. So that improves your quality. All that leads to improved profitability. That's the first level of value. The second value, and I think this is where it's really exciting for this forum, is it allows us to rapidly reconfigure manufacturing cells with heterogeneous robots. And I think that's a really great place we are in the industry, that the platforms have matured. There's an enormous diversity of platforms today. And really, how do we begin to put those together in ways that we can quickly adapt manufacturing? And you begin to think of topics like high mix manufacturing. How can I do different things on different days? We're really an enabling technology for that. In addition, we're a bridge between the physical and the virtual. And I think the sensors and the technologies that do that are super important. I think a lot of the panelists who are, going to talk about AI today, making sure we have those bridges between the physical and the virtual are super critical. And it's really how we tie all of that together. So it's great to be kind of one of the foundational meshes, if you will, in that ecosystem and helping our partners enable there.
Very good. Thank you, James. Deepan, I'll have you go next. Just a little bit of background on what you're doing at Voyage.
Yeah, absolutely. Thanks. We're a software company, and we build AI vision software for robotics. The way we like to describe it is AI vision software with physical intuition. So if you have a robotic arm and you have a sensor and you know what to do, you might face this challenge about, okay, I see what I have to do. I have to pick up these parts, pick up these SKUs or food items, whatever that is, and pack them, whatever that is, what do we need to do? You have to figure out how to grab something, and you need to solve a pretty hard computer vision problem for doing that. We provide a out-of-the-box solution for that problem. So whenever you want to pick up something, pack something across food, logistics, recycling, ag tech, manufacturing, and you don't have CAD models for this, you have not seen these parts before, you have not trained on them, we solve that today. So we can pick up things without ever seeing it before. We can pack things without seeing it before. So just solving that critical AI vision piece in that entire value chain is what we do. So we don't build hardware, we just a purely software component, software product, enabling automation to tackle harder use cases, expand the market for all stakeholders in the industry. So you can actually say yes to projects that were previously difficult to do. And that we have seen is the most valuable contribution that I think we are making to the industry, solving that hard problem. Yeah.
Very good. Very good. And Raj, can you talk a little bit about the work you're doing on the AI side of things for some of the robotics functionality that James and Deepan have mentioned?
Yeah, actually, so at iMerit, we are probably the third pillar here in this robotics value chain. We at iMerit provide custom technology and human expert services for annotation and other ML data ops across a wide variety of probably a dozen different verticals and use cases in the industrial and manufacturing space. We are unique in that we provide a technology platform that includes the data pipeline automation, including model plugins and integrated data annotation tools, custom analytics, reporting, business insights, with a perfect symbiosis with the experts in the loop for when human input and oversight is needed. You know, in my opinion, very few companies, frankly, if any, offer such a solution in a single integrated end-to-end platform that is also fully flexible for our clients' custom business needs. And as AI moves from this development to a production at scale, I think business viability, along with what we usually call the 3 M's of AI, model management, moderation, and mindshare or trust, has become paramount issues that need to be addressed with a combination of human expertise, scalable and flexible technology, and of course, automation. And that's what we strive for our clients in this sector as we address their unique business needs with very custom technology and expertise solutions.
To those comments, I want to go back, James and Deepan, a couple of things you each said. When you look at how your robotics functionality has evolved, what would you consider to be the biggest enablers that have advanced the functionality of your different robotic systems? And maybe James, start with you, and then Deepan, please jump in after.
That's a great question, because there's so much. Like, it's hard to put just your thumb on any one thing. I think, you know, if I could look at almost a more macro trend, I think that when you talk about just the last decade is, you know, last few years even have seen an enormous growth in the number of platforms. I think that's just increased the accessibility to it, which kind of has just triggered a whole layer of innovations. And that's where, you know, is there any one magical thing that's just clicked? It's hard to put your pin on it, but I know, you know, I went to Automate for the first time this year since before the pandemic, and it was amazing just to have seen the growth in innovation there. And I think there's just, it's hard to say there's one breakthrough at this point. I think there's just so many breakthroughs going on at this point that's, you know, and it's more just, it's gone from a concept, I think, at this point to a reality. And it's not, you know, are the individual pieces there? It's how do we put it all together to realize really what has been this decadal dream, if you will, of, you know, Industry 4.0 or agile manufacturing. But it's the, you know, we've really almost reached that tipping point where there's so many people involved. There's so much access to it now that there's just, you know, an incredible breadth of innovations at this point.
And Deepan, from your side, what have you felt has been some of the bigger enablers?
No, I think James put it quite succinctly as well. I think there's a lot going on, the different pieces in the value chain that are coming together. From our standpoint, from the purely AI standpoint, something that blew my mind was how LLMs have been really handling the amount of variation. How you can program something very easily and you can respond to it. Now that's in the language space. How that pertains to robotics is, it's really hard, or was really hard to explain a complex task to a robot.
Mm-hmm.
It was much harder for it to handle the variation that it was presented with. And that was almost like one of the key bottlenecks that is, I would say, honestly, stifling growth for the entire industry. So robotic arms have gotten way better, let's say. Sensors have gotten way better. End effectors and grippers have gotten way better. So all these mechanical aspects have been like constantly being developed, yes. But there's also like the software component of pieces that have gotten actually quite powerful. We just provide one aspect to it. We just provide the physical AI part of it. But there's so many other components. Like, how do you describe saying, hey, I want you to pick up this part and pack it in this box in this manner extremely quickly. That lets you reprogram robots very quickly and cheaply. Now, if you are able to do that and it can handle the variation, suddenly the SMB market opens up, where there's going to be much more changeovers coming in. What I mean by changeover, basically, for the audience is, you want to do this task in the next hour, you want to do something else completely. Programming the robot very quickly is almost impossible right now. It's not easy to do it within such a small period of time for a particular part. But AI lets you do that, and suddenly the smaller business SMB market, which is frankly the largest in the US in terms of the market share, that tends to see some growth, and that's to see some adoption coming in, and that's going to really transform the economy as well. So I'm really excited about making robots easy to program and having them handle much more variation than previously.
And to that point, the idea of being able to have robots do multiple functions within a warehouse or a manufacturing setting, what you were just describing, Deepan, Raj, how do you feel AI is enabling that level of advanced functionality or addressing this and moving what functionality can be farther forward? What's your thought on that?
I think it's really about what we call as the 3Ds. The dull or the mundane, the dirty, and the dangerous. Getting this work out of the hands of an operator, enabling the operator to enable this robot to be trained, or this AI algorithm, or whatever it is that we deploy out there, and not replace her duties completely. And then I think one thing that comes up a lot in our vocabulary is the word mundane, and I think that probably needs a little bit of pondering. For example, we do a lot of work for the manufacturing companies on defect detection in an industrial setting, for automobiles, for steel and metal, for natural materials like granite, marble, etc. None of these are especially challenging for humans, defect detection. But it's the tedious or the mundane nature of the work that reduces efficiency and accuracy, raises costs, and makes the need for automation absolutely paramount. It doesn't eliminate the operator, but makes her job much easier, resulting in longer shifts, higher efficiency, and 5 to 10x or sometimes even more higher accuracy is what we are seeing. Actually, we've arranged a quick demo of this application later in the story, and please join us there. And I think we'll also have a PR around a solution customized for manufacturing verticals. But I think that's the key over here, which is about this 3Ds and not attempting to replace operator's duties completely, but to really enable her to take some of her 3D work and teach the robot how to, or the application, how to help her and augment her. I think that's the key that we think AI is bringing into this picture.
And James, from your side, as you're developing your robotic systems to what Raj was describing of 3Ds and what would be considered mundane or highly repetitive activities, how is that influencing your product development, your strategies, you bring your robotic systems further forward?
Yeah, I mean, Raj brings up that great word mundane, which you really have to put the context behind. And I think for us, it's become a powerful way of shaping our product roadmap. And I think when you start off on a startup journey, you start with this grand vision. I'll take a lesson we have from another product line we have in rail transportation, which is developing positioning for automated trains. And you can say, okay, you've got this grand vision of, you can, increase automation for the trains, less workers, more, better on-time performance. It's a grand vision. But what we learned along the way with that was that same data that you collect in solving that problem can be used for a very mundane task of looking at the health of your system, track defects, train defects. And I think I use that as a lesson here in robotics in general. I think we often go to how do we do, let's fully automate our line today, right? And what you say is, okay, there's a lot you have to do to fully automate a line, and it's the ecosystem, and you might not get there today. It might take you a while, but look for the mundane things that the humans are doing today, like Raj brought up, and can you add value there and solve that part of the problem? Because if you do that, you get into a virtuous loop of you're advancing your own product capabilities and you're solving a customer's problem today where they can then, reallocate a worker to a higher value task. And I think that's just a really beneficial cycle. And it's a great context to put things in when you're looking at your product roadmap, because it takes a long time to build these grand visions and to achieve, a full ecosystem of your technologies everywhere solving the biggest problem. But there's a lot of mundane problems along the way that can create value for your customer and for you. And learning those and implementing them is just a great way to get your product out there and just increase your exposure into the markets and build your business, really.
Hey, James, you said something earlier I want to go back to and get deep on your feedback on this as well, is where are we in that migration to having factories where we're doing multiple types of robotics activities on the same line or the same level of adaptability? How are we in that evolution landscape? What would you say our current state is and where we're headed next?
That's a good question. So we work with manufacturers, yes, but one of the major industries we're working with food. And in food, it's a process line. So manufacturing SMBs have like these batch lines. So it's not really a process that people take parts here and there. So that clearly has a lot of variation going on. With food, it's interesting because you have changeovers in terms of what the item is being handled. I mean, cupcakes can change, donuts can change, and something else as well. But what we've seen is most of the food industry is actually not automated because of that variation. It's interesting. So since you have this, even though it's dull, mundane, and some cases dangerous especially with slicing meat and all that, it's not fully automated actually on the meat production side of things, for example. So there are many pockets that are lacking automation, and frankly, one of the things that we've seen is because of technology is not there yet. So the end customer needs it. They have the budget for it, but the tech isn't there yet. Now, those customers are easy to sort of talk to because they see the value. Some of these other customers, James put it very well, which is we have to sort of decide what to build for them. So we have to ask them, hey, where are you seeing the highest amount of turnover, let's say? What are you having trouble with? Are you having trouble hiring people? There was this one logistics facility I spoke to, which said it takes them about a month to sort of like train someone for a particular task, and then a couple of months to find this person in the first place, but then they leave about like 2 months. And then just doesn't work for them. So these kind of customers are very easy to talk to because they tell you exactly, they literally mention the problem quite strongly, and then you already have an idea about what to build. And as James also mentioned, the biggest question that every CEO needs to decide for this team is what product to build. So frankly, the 3Ds are actually shape our roadmap as well. Yeah. Speaking of those, sorry, go on.
No, it's great. I'm thinking about food handling and this notion of edge cases where maybe you're supposed to be picking certain types of foods for certain types of fulfillment, and all of a sudden something goes awry. How are you dealing with edge cases? And I know, Raj, your team spends a lot of time looking at edge cases and trying to figure out how to handle these anomalies that come along in manufacturing and warehouse fulfillment. But I'd love to get your thoughts on, as these things happen, how do you nimbly handle those and not interrupt your operations?
Yeah, absolutely. I mean, we deal with edge cases a lot, sometimes probably a bit too much. It's all about edge cases. And I think, as we talked about briefly, business success for autonomy or any AI solution, I think it's really about edge cases, right? I mean, as you look around, and it's not just the manufacturing vertical, right? AI applications are judged not by the 99.9% of the time that it gets things right, but it's that 1 or 2 corner cases where it did not, right? And so what we primarily deal with is how do you triage these edge cases in the field and feed it back into the dev and test cycles of ML ops. As clients' application moves from training to production, our role, what we have seen, changes from these annotation services for training, which is about getting the technology right and the edge cases around labeling uncertainties, etc., to getting the business right, which is essentially, like I was saying, monitoring performance metrics in the field, triaging the anomalies that arise that the model or the application couldn't handle, and then using human expertise and automation where each one of them is relevant. Usually it's a symbiosis of the two, and then feeding those results using either production data or synthetic data, or I think more often the combination of the two, back into the test and dev cycles for model tuning and validation. In the defect detection solution that I was talking about in the example that we will demo, we give you a glimpse of an edge case detection and a very simple application of a real-time triage that happens in the manufacturing that we've done. Of course, we do a lot more custom and complex work for specific verticals, but I think what we are seeing here is that as we focus primarily on taking care of edge cases in the field and addressing those further upstream in the MLOps cycle times are getting reduced. We are moving from, for example, batch processing and learning to real-time learning. SLAs are getting tighter, and we are doing this day and night and allowing our clients to be more efficient and adaptive. So in other words, edge cases is essentially what's making the business of AI applications tick for our clients.
Hey, James, I know we got a few minutes left. Just real quick, how are you thinking of edge cases and how that influences performance of your robotics operations? And
I think Raj is spot on that. It's really, I think, a multi-layered. I'd say there's a couple tenets. One, it's a multi-layered approach. There's no one right thing. You'll never collect enough data for these applications, probably. Sure. You'll never make the perfect simulation either. So you have to be doing a multi-approach. And we do a lot of what Raj pointed out. When we see edge cases, we quickly triage them. We make sure they get folded back into our CI/CD pipelines. And I think that really leads to the second tenet, which is never let the same edge case catch you flat-footed twice, right? And how do you keep that institutional knowledge continually growing and learning on that? And it's just super critical. So I think we're looking at it really, summarizing, a multi-layered approach, including sometimes analysis, including, talking to customers to really understand their ConOps, so we can understand, are we looking at reasonable use cases that have and what those outliers would be. And second, just, whenever we see one, making sure that, not just the processes, but the culture ensure that what we've learned from that edge case, is embedded into our product, into our customer success teams. And, you get caught once on the edge case, great, but, you with confidence, you've resolved that edge case moving forward.
Very good. One sentence, quick response for each of you. If you had to forecast what workforce robotics is going to look like 10 years from now, what is that going to look like? Deepan, you first.
Oh, wow. That's hard to put in a sentence. I think we're going to be, I think we're going to be getting rid of a lot of the 3Ds kind of tasks, and humanity probably will be society will be moving towards some of the more interesting tasks that we probably doing. I do see that happening, most likely.
Okay. Raj, how about you?
Yeah, we joke about this a lot. It's going to be, so we already have, every human already has 2x the arms, but we will have twice the number of eyes, twice the number of ears, twice the number of legs, and we can touch and feel a lot more. So yes, manufacturing automation is going to move there. It will not replace the human being, but it will significantly augment a human being and make him a superhero.
Love it. James,
humans will be doing a lot more, and they'll be spending less time looking at data, and AI will be giving them information and actionable insights that allow them to do their jobs more effectively. And when you look at the workforce and the shrinking workforce, that person's going to be able to increase their productivity, which is necessary. We won't be doing the grand vision stuff yet, but we'll have, I think Raj put it great, we'll have more superheroes in the workforce.
I love the third arm idea too. It's fantastic. Gentlemen, we're at the end of our session. This has been fantastic. We appreciate your input.